happened, because it's a source of pride that their profession contributed to an achievement like this. And then, of course, within the United States, we're all very proud that our country made this achievement. So there's a real reluctance to question anything that would destroy this lofty self-image. And particularly for the people who worked on the Apollo program, to many of them this was the most wonderful achievement that they ever produced during their entire life. And they would much rather think of it that way than to think that, like millions of other people, they were fooled into thinking they were working on something that was not genuine.
I think the idea that the Apollo project was faked is demonstrably ridiculous. I think it can be demonstrated that this is the case from a large amount of evidence, both scientific and indeed just common sense.
H.J.P. Arnold is an astronomer and very keen photographer, an expert on space and astrophotography. He was assistant to the managing director of Kodak Limited during the period of Apollo. He's also the author of many books on space photography and exploration.
This is a roll of, as you can see, 70mm film, and this is, of course I hasten to say it's not the original, which is in the closely guarded and temperature and pressure controlled vaults in Houston, magazine 40 from Apollo 11. So this is the roll of Ektachrome film that was exposed mainly by Neil Armstrong on the lunar surface, and of course it's a historical record, but I do stress that this is a duplicate which was given to me, and I'm very proud to have been given it by the people at the Photographic Technology Division in Houston.
Brian Welch is Acting Director, Media Services at NASA Washington.
The film was specially produced for NASA by Kodak. It involved the use of thin gels and special emulsions for this film. The idea was that it would have to stand up to a vacuum, it would have to stand up to extremes of heat and cold on the surface of the moon.
But H.J.P. Arnold has a completely different view regarding the film used.
It was Kodak film, and the sensitization of the film was essentially the same as ordinary film at that time. It was Ektachrome X, as it was then called, 64 ASA, or ISO, as we need to say now. ASA is all gone. Or 160, which was then a very fast film, of course, at 160 ASA or ISO.
So, it turns out that the film emulsion was perfectly ordinary after all. Then perhaps the camera itself was special. Hasselblad in Sweden was the NASA-appointed manufacturer of a camera capable of functioning on the lunar surface. And Jan Lundberg was the project engineer responsible for building the camera.
Originally, NASA made all the alterations themselves. Then they presented what they had done to us and asked, can you do this? And we said, yes, we can, and we can do it better. So after that we put up a technical specification which was approved by NASA, and then all the alterations were made in our factory.
Was the film loaded into a regular camera magazine?
It was a modified standard 70mm back. There were protective plates both on the camera and on the film magazine.
On all the NASA still photographs taken by the Hasselblad lunar surface camera, one should see small crosses spread at intervals over the surface of the image. In the center of the image, there should be a larger crosshair, or reticle as it's called professionally. These reticles were virtually in contact with the film and set in the focal plane of the camera at the time of manufacture by Zeiss. This means they are immovable. Any photograph purporting to be taken on the moon by the named Apollo astronauts using these lunar surface cameras must feature the large reticle at the center of the picture. Not only that, it would be totally impossible for an object to get in front of the reticle on the developed image.
So what exactly are these reticles or crosshairs for? What do they do?
They can measure this distance between the crosses and also determine if the film has curved, because then the crosses will be slightly dislocated.
So what is NASA's opinion on the reason for the reticles?
Those are there in those photographs in order to provide the engineers with the ability to measure distances. They would knowing the way the photo was put together, they would be able to use that to measure things off in the distance, and so that's why they're there.
Did the reticles also help to judge distances?
Not actually.
Because that's what NASA says the reticles are for.
Well, to do that you need a stereo pair.
However, the Apollo pictures, those with the reticles, were not taken as stereo pairs. Let us now look at some further basic photographic principles and examine some more of the Apollo photographs to see what anomalies might come to light.
In these Earth pictures of typical tree shadows, notice the parallel lines of shadow on the ground, and also that the shaded side of the trees is very dark, which does not allow for any visible detail. These points are both logical and unsurprising. Now compare the tree shadow pictures with this shot allegedly taken on the Moon. This is the designated landing site of Apollo 14. The area where the LEM is located is virtually flat. But one can calculate from the diverging shadows that the source of the illumination is within the area of the scene itself, apparently overhead. In other words, it cannot be the Sun. It's possible to work out exactly where the light source was positioned, because the shadows diverge from a point here, when in fact the shadows ought to be parallel. The Sun creates parallel shadows. The shadows cast by the rocks in the foreground should have been east-west, like the LEM shadow here. When natural sunlight is illuminating objects on flat terrain, this result is impossible, but this result is consistent with illumination from a closely positioned artificial source of light.
Should we then take this matter of artificial lighting very seriously?
Yes, because according to the official record, no artificial lighting whatsoever was taken to the Moon. Compare NASA's photograph with our computer-simulated image. The light source, the Sun, in our simulation is located far to the west, the left-hand side of your screen. And in our illustration, all the shadows are falling, naturally, due east. We must therefore irrefutably conclude that an artificial light source was used in close proximity to this alleged Moon location in order for NASA to obtain the non-parallel shadows seen here in this photograph. Let's go through some more examples. Here is a Honda press advertisement that's used a very interesting mix of shadow directions. For the sake of argument, let us take it that the cars were the primary subject of the photograph, so they were the beneficiaries of the prime source of natural light, the Sun, and the very, very short shadows created by the cars themselves indicate that these were photographed near to midday. The Sun's direction is from the bottom right-hand corner. The palm trees, however, have been photographed when the Sun was further round, nearer to setting, and therefore creating these very long shadows due to the Sun's closeness to the horizon. This is an example of a composite picture containing two differing sets of shadows, a composite that incorporates the message that there have been time delays between the components that make up the final result. For Honda's purposes, this discrepancy doesn't matter. But to see the same type of composite manifesting in the official record of Apollo is more than enough to alert us to the fact that something's very wrong.
Can you then give an example of this from an Apollo mission?
Yes. Crossing to Apollo 17, here is a picture of Jack Schmitt digging. His shadow is extending in the same direction as that of the cars we've just been looking at. The source of light is from the bottom right-hand corner of this picture. Yet if we look towards the right of the scene, we can see that the shadows of the middle distance rocks themselves run from east to west, shown here by the green lines, the secondary light source. The yellow lines indicate the direction of the primary light source, allegedly the Sun. Now this situation is impossible naturally, and has to be the result of more than one light source and/or technical manipulation and doctoring of the image. If we look at the shadows of the rover's wheels in this photo, we can see that they are somewhat diverging, as shown here by the lines, and as we tilt down we can see that this rock here, halfway down the picture on the right-hand side, is producing a shadow that extends diagonally to the lower part of the picture, as is the shadow for the foreground rock, the rock with the letter C marked on it, originally noticed by fellow researcher Ralph Rene. Let's pause here for a moment and ask why there should be a letter of the English alphabet stamped onto a rock on the Moon's surface, and why there's a C also marked on the ground just in front of this very peculiar looking rock. How could this be? Surely we're looking at the deliberate planting of props, on a previously designated portion in the foreground of a photographic film set. Does this planted C stand for centre, or is it perhaps C for light, artificial or otherwise? For this is the letter that represents the physical constant of the speed of light as it's presently understood. If early probe images from the Moon had demonstrated that natural lighting conditions there would not reproduce consistently acceptable results due to the gravitational anomalies and possible variations in the behaviour of light, the subsequent use of artificial lighting in the pre-creation of the lunar surface imagery makes a lot of sense, as does this whistleblowing clue.
The fact that the speed of light may not be a constant is only just beginning to be discussed openly beyond scientific circles, but of course variations of light speed at specific periods have been observed over the years. It could well be that the speed of light varies according to local gravity fields.
Coming back to shadow anomalies, here is an example of a Mongolian herdsman, photographed with the light behind him. And of course, if a photographer is exposing for this scene, he or she knows perfectly well that without the use of fill-in flash or other lighting near the camera, there's going to be a result that looks more like a silhouette. Now look at this picture of an astronaut spacesuit, which was taken in a studio. The prime or key light is from the right, the upper area of the picture, and the area by the shoulder, here on the left, is much darker. So parts of the subject have been filled in with light in order to give us more detail. And indeed this fill-in light is square in shape and has been reflected by the visor. We propose that this technique of using extra fill-in light was applied when certain Apollo close-ups were created. Here we have the Sun, allegedly the only lighting source available to all lunar photographers, directly behind the astronaut and directly behind the rover. And remembering our example of the Mongolian herdsman, with no extra lighting and no atmosphere to help diffuse the light and fill in the subject, we must expect the authentic lunar surface picture to look like this, with both the astronaut and the rover in silhouette. Yet in this NASA Moon photograph, as published, we can see detail on the shadow side of the astronaut. To say this once more, such detail can only be revealed by the use of an additional light source. So we have to conclude that secondary lighting was used to create these alleged lunar surface pictures.
Were any lights used in the lunar surface photographs?
No. They had no extra light sources brought with them.
At this point, let's consider some of the important initial imagery allegedly taken on the surface of the Moon by the Apollo 11 astronauts. Another individual named Bill Wood, working at Goldstone Tracking Station in California, played an important role throughout Project Apollo in delivering the communication links to and from the spacecraft. What were conditions like on the lunar surface at the time of the Apollo 11 moonwalk, or EVA? And if it was so dark in the shadow of the lunar module, the LEM, did they, for instance, use a special low-light lens on the camera?
Astronauts would go down the ladder essentially in deep shadow. They would only be illuminated by something reflecting off of, light reflecting off of something else. And I believe that they felt that they needed as much light gathering power as possible. That was the lens that was used on Apollo 11, the so-called night lens.
If the Apollo 11 TV footage was taken using a night lens, then what about the still photographs? We have to ask how they produce such good results, because the stills camera was not specifically designed for low light conditions, and the camera was not fitted with a special night lens.
In the Moon, where you have no atmosphere, shadow is black and highlight is really violent highlight, so you have an enormous contrast problem.
We're reliably informed, to emphasize this point again, that no extra lighting was taken to the Moon. We've taken the TV coverage and intercut the relevant still pictures.
Okay, your plus looks like it's clear and okay. The toes are about to come over the sill.
This is the first of a sequence of photographs of Aldrin descending the ladder, taken by Neil Armstrong during Apollo 11.
Now drop your plus down. There you go, you're clear.
A number of sources, as well as the many reference books on the subject, emphasize that the shadow side of the LEM was in total darkness, and this fact is also confirmed by the TV coverage itself. You could call it designer gloom in comparison with the still photos. In this still picture sequence, Aldrin is apparently lit. In other words, an artificial light source has turned what would otherwise have been unusable, gloomy pictures into images of virtual studio-like quality.
Visibility, as we've said before, is not too great. Okay, I'm on the top step and I can look down over the RCU and landing gear pad. Okay, I'm going to leave that 1 foot up there and both hands down to about the 4th rung up.
So here we have Aldrin, descending the ladder in total shadow. But we have evidence of the use of artificial lighting in the still photos of the event, because we can see that lighting is hitting part of the porch, the backpack, part of Aldrin's spacesuit. And most notably, it is hitting the heel protector of his right boot. It is obvious to anyone who understands photography that secondary lighting was used in this image. Reflectivity of the lunar surface, incidentally, is so low that it doesn't even manage to illuminate the rocks on the surface near to the ground. So we cannot accept the argument that the astronauts are beautifully lit even into the porch area of the LEM due to lunar surface reflectivity.
I think the idea that the Apollo photographs were faked is extremely unlikely. I think you have to remember there were 6 successful manned Apollo landings. So the idea if something had gone wrong in the first one, then of course it would have been pretty simple to fix it for the other ones. The other thing you have to remember is although there are 2 or 3 perhaps really famous photographs from the Apollo project that most people are familiar with, really tens of thousands of photographic images were obtained from the surface of the moon during those missions. So the idea that they were all faked really seems pretty unlikely. And to be honest, it would be extremely difficult to fake those photographs because the environmental conditions on the moon are really different from the environmental conditions on the Earth, or even different from the environmental conditions you could easily duplicate in a studio.
David Groves of Quantec Image Processing, using the technological resources at his command, has traced this secondary light source and been able to calculate exactly where an additional light was placed in relation to the camera.
If you magnify the photograph and look at the boundary of the porch through which the astronaut is exiting, you can see a fine shadow line around the porch perimeter. This shadow line shows that you have a well-localized source of light to the right of the camera. Most interestingly, there is a hot spot on the heel protector of the astronaut's right-hand boot. This allows us to do some quantitative measurement. We had access to one of these boots with a heel protector from which we could measure very accurately the curvature of that heel protector. Knowing again the focal length of the camera lens, the position of that hotspot on the heel protector and the orientation of the boot in the photograph, we could determine the light path to that source of illumination. The light source is between 24 and 36 centimeters to the right of the camera, an ideal position for artificial lighting.
So it's now been established beyond argument that an artificial light source was used. We even know where it was placed for the photography of this important sequence of Aldrin descending the ladder. At this point you might say, well, surely they can use extra lighting if they want to. What's wrong with that?
According to NASA, the astronauts didn't take any lighting to the moon. And we can prove that there was no lighting. The TV coverage of this event demonstrates this fact.